Este es un contenido de Uninorte Académico. Suscríbete, aprende y comparte.
Energy in a changing world. And our chairs for this session are firstly Dr. Vanessa Magar, who is on faculty at the Physical Oceanography Department at the Center of Scientific Research and Higher Education in Ensenada, Mexico. She's also currently a visiting scholar at the Edinburgh Parallel Computing Center, or EPCC, at the University of Edinburgh. She's a physical and coastal oceanographer with expertise on wind energy and marine renewable energy. Our second co-chair, is Dr. Hector Chavez, who is the director of the Department of Electrical Engineering at the University of Santiago, Chile. He is an electrical engineer who studies the technical and economic impact of sustainable energy on energy systems. And I will hand it over to them to introduce our panel.
Well, we have been discussing how science is being contributing to sustainability. That's what this symposium is all about. So now is the time for energy. In the other talks, we have been seeing that our oceans, our food is being affected by climate change. And climate change is mainly caused by anthropogenic CO2 emissions. That's a fact. Now, if you see that energy is responsible for 3/4 of those emissions, so energy seems to be important in that context. Now, energy systems that are carbon neutral are very complex, and that's something we would like to discuss in this talks. Well, large public policy and economics, everyone knows that energy involves very large, massive infrastructure, massive amounts of money. So there has to be economics in between for making public policy, for making regulations that are appropriate for different contexts. Then we have security of supply. Security of supply in the sense that energy that is being generated and consumed must be the same at all times in different scales. And that has a lot of physics in between. So we have to take into account different physics perspective of the energy problem. We have energy that is renewable, and we have that in a not really good shape, which has variability, has uncertainty, and we cannot just agree on not having that. There's no public policy, there's no agreement that can just erase the fact that we have that variability. So we cannot overlook physical models as well. Energy poverty. Our countries have that. Our countries need to advance in carbon neutralization in parallel to energy poverty, and that's also a problem. Now, we are trying to embrace these three things, and we have our panel, which is Karina Busboski from Argentina, Osvaldo Rodriguez in Mexico, and Lira Lázaro in Sao Paulo. They do not work in the same things. They do not have the same backgrounds, but they do work in the same field, highlighting the fact that this energy problem is very interdisciplinary.
Okay, thank you. Well, first of all, I would like to say that I am very excited for all of us to be here and to be able to share our knowledge and expertise, and hopefully there will be a lot of collaborations coming out from this conference. Following on from Hector, we have these three panel speakers, and we're very honored that they accepted the invitation. They will talk about complementary problems related to the energy and the energy transition, from the perspective of the economic and the political agendas of our different countries, the security of supply, and as well the problem of the trilemma or quadrilemma in the energy transition. We have as well the perspectives of the countries that they represent, and I'm sure that you will see your countries reflected in this. So without further ado, I will introduce our first speaker. Karina Gusowski is currently Associate Professor of Energy Economics at the Department of Economics in Universidad Nacional del Sur, Bahía Blanca, Argentina. And she's a researcher at the Instituto de Investigaciones Económicas y Sociales del Sur, CONICET UNS. She has specialized in the study of energy markets from the perspective of economics and the regulation of these markets, with a particular emphasis on economics, climate change, regional integration, and public policies, and the development of a systemic knowledge of the energy system and its links with sustainable development and the environment in Latin America. She holds a master's and a PhD in economics. So the floor is yours, Karina.
Well, hello, I'm Karina Gusowski, I'm an economist, I'm from Argentina, and I work in things related to energy transition, to energy economy, and its impact in the society. And today I want to share with you how is my perspective about the energy transitions in Latin American economies. Well, the first slide is about which are the features of our energy transitions in our region. First of all, I want to share with you that the energy transitions is a crucial issue, it's a crucial theme today in our economies, in the world, and in our region, in Latin American region. It's an ongoing and irreversible phenomenon with big consequences at local and international scale. And what is the energy transition? The energy transition is really an structural change in the form of the people consume and produce energy. The energy transitions imply goes to a cleaner energy matrix, and an important point from an economic and regulation point of view that it's not an immediate process. It's a process that is a long-term process, and it's important that we can recognize that it requires to implement public policies and coordination of different situation of different dimensions. And this point is very important. I return to this point at final of my presentation because this last point implied that the state that the energy transition require the state to implement these policies. And what is the principal characteristic of the current energy transitions? The objective of the actual energy transitions is reduce CO2 emissions. The energy transitions has a lot of drivers, but the most important drivers of the energy transitions is introduce renewable energy in the energy matrix, introduce policies of energy efficiency, introduce policy to distributed generation, to sustainable mobility, to energy efficiency, and introduce policies related to hydrogen, clean hydrogen in our energy matrix. Is this the first energy transition? No. in the world were other energy transitions with other drivers, but the drivers of the currently energy transitions is the climate change, is the need to reduce the CO2 emissions. And it's very important for our economics explained and discuss just energy transition, which is the just energy transitions. Our economy have a lot of poor, and the energy transitions perhaps will be a possibility to our poor population to access a modern energy, more energy with less impact on the environment. Then these situations name just energy transition. The just energy transition is the possibility to the poor population to access to modern energy. The energy transition isn't a simple problem. It's a complex problem, and then we are talking about this situation. And it's a complex problem because it implies a technological, a social, a political, a regulatory, a legal process. And it involves different actors, both private and public actors, whose interests are not always aligned. It's very important to say that there are common but differentiated responsibility for CO2 emissions, as our economy, with 8% of the world population, is responsible for 8% of human CO2 emission. As you know, in this slide, you can see that our region, Latin American economy are clean. Our matrix, our energy matrix are clean. For example, when you see power generation, you can see that 45% of our power generation is hydroelectric. And you can see that almost 20% of our energy matrix is by hydroelectric, and 10% of our energy matrix is by renewable energy. Then we can say that really we are a clean energy when we talk about energy matrix. When you can see the emission by sector, you can see that in our region, the responsible of the emission are the energy sector, but too the agriculture sector, the land change are responsible of the emission. Then the policy must focus in the energy sector, but too in the agriculture sectors, in the land use in our region. And it's very important too that when you see the energy emission by subsector, you see that in our economies, the transportation sector is very important to explain our emission, the transportation sector and the electrification head. Then it's important that the policy focus in the transportation sector. How will be the transportations in the future in our region to reduce the CO2 emission? Really, what happened in our region? The renewable index of the regional electricity matrix will reach 75% 30 years ago, but currently reached 59% by the end of 1991. What are the reason why this process is not advancing at the pace it is in the rest of the world. Why the participations of the energy, of the renewable energy in our matrix reduced from 30 years ago up to now? Well, because there are different barriers. There are political barriers, there are social barriers, there are institutional barriers. Our country, for example, my country, Argentina, in this moment, is past an important political, economic, social problem that impede, that restricts the possibility to introduce more renewable energy in our matrix. There are different barriers, infrastructure barriers, a specific barrier to development of new projects. And what will happen is all of these barriers can overcome. Well, how will be the energy transition? It must be fair, affordable, and sustainable. It must simultaneously have social, macroeconomical, fiscal, financial, and balance of payment consistent. This last situation is very important, for example, for my country. The focus of the region climate actions must be on climate change adaptation rather than the obligation to continue reducing emission from the electricity sector. This is very important too. Then the energy transition for our economies must be an opportunity to decarbonize the energy transitions and to put more technological and productive capacity in our companies. And the energy transitions must interact different dimensions. The energy transitions in our economy must secure energy security, energy access, environment sustainability, and the energy transitions in our economy must focus in an opportunity to a techno-industrial development. The energy transition must be an opportunity to our companies to create green employment, to create spillovers over different sectors and different parts of our economies. The energy transitions can be the drive for the export and industrial development program of Latin American country. Then the last reflection is the energy transition is a global phenomenon that goes through developing economies. Latin American countries have different metric to European countries, which is the origin of the concept of energy transition. We should not import the agenda of developed countries in terms of transition. It is better to think of transition, of different transitions, where each country builds its own according to interest and its natural resource endowment. It's very important to understand that each country must construct each energy transition. For example, my country has a lot of gas, has one of the most important reservoirs of natural gas in the world, named Vaca Muerta, in the south, in the Patagonia of Argentina. Natural gas for my country is an opportunity to the energy transition. In Argentina, for example, we can't talk about energy transition without talk about gas. And perhaps you see, well, gas is a pollutant energy. Yes, it's a pollutant energy, but it's less pollutant than carbon, for example. And gas for Argentina is an opportunity. It's an opportunity for our companies. It's an opportunity to create more employment. It's an opportunity to have a currency, to reduce the instability for our economies. Then this is the idea of this presentation, no? That we can't talk about only one energy transition. In our region, we must talk about different energy transition for each country of our region. We must construct each country their energy transition with their endowment. And I believe that is the discussion, and I want to introduce you in the final of this session. Now, how can we construct our energy transitions in our country? And I really note that the challenge for Latin America is to develop the energy transition by promoting national techno-productive capacity. This is central. This is a key idea. The energy transition for our country not isn't only a possibility to export primary materials to the developed countries. The energy transition must be a possibility to introduce techno-productive capacity in our country with spillovers in other industry, in other companies, in other sectors of our economy. In Argentina, we have an energy plan, an energy transition plan, and this is the central point, the opportunity to introduce techno-productive capacity. But we need a great challenge for our country is to reduce uncertainty, to provide predictability. The investors, the private investors, we need private investors. We need the state. We need the state, but we need the private investors. And the private investors need provide predictability. No, we need to build trust and to enforcement. A relevant idea that is, how is the time? Okay, the relevant, the final idea that is we must construct the energy matrix in our regions, and we need the public policy. And this is a very important point. We need the public policy. We need this sector, need planification for the long term. And the public policy is a key issue that we need to discuss in session like this. And the final idea that is each country has to do what is more convenient for them, and international cooperation has to make what suits the country, suit the world as a whole through financing and technology transfer. This is very important. We need the cooperation, the international cooperation. We have a lot of part of our economy with the population in situation with poor population. And then the energy transitions need financial support. And this financial support imply an international cooperation. Well, there are several questions that I have in my mind about energy transitions, about how Latin Americans make the transitions into an opportunity. And I want to discuss this in the last part of our session. Thank you very much.
Our next speaker is Osvaldo Rodriguez. Osvaldo Rodriguez is a full-time researcher at the Institute of Renewable Energies of the Universidad Nacional Autónoma de México. His research focus is on the evaluation and analysis of the wind resource with meteorological models and experimental data at the national, regional, and local levels, as well as wind resource variability analysis over time for small and large capacity wind turbines. The methodology developed has been implemented for other sources of electricity generation, laying the groundwork for designing networks and microgrids with high renewable energy penetration. He is a physicist by training and holds a master's degree and a PhD in energy engineering. Osvaldo.
De acuerdo. Hi, everyone. First of all, thank you for the organizers for having this opportunity to share what we've been doing in the institute, the place that I work. My name is Osvaldo, and okay, let's move on. This is the outline. Okay. Yeah. Okay. Well, we need to put a wind turbine there, right, to move the slides. Okay. So this is the outline. I think when I talk about energy with my students, I always say that when you speak about energy, you need to talk about money. So I mean, this panel is it's a good example that it's a reasonable idea. So I will start speaking about what's been going on about energy in Mexico. Then the final remarks, I will take some ideas of that first slide. So this is a total spoiler of what I'm planning to do. And in the middle, I will speak about how we use reanalysis data as a powerful tool to plan, to identify this variability, to study this variability of the renewable energies, because everybody knows that the first argument when you talk about renewable energy is that it's a variable source of energy. And the issue is not that the renewable energy is variable. I think that the issue is the demand is variable also. So we need to match to those two time series, and that's a huge task, right? So, and I will share two of the examples how we've been addressing this issue in the thinking about what will happen if we put some wind energy offshore in the Gulf of Mexico, and also if we can find some way to reduce this complementarity by interconnecting wind and sun complementarity. So, okay, this is one slide of Mexico history in the topic of energy. So I think that like in the main, in all the world, we have a boom of economic growth by using fossil fuels. So Mexico is not the exception. Specifically, we have this opportunity to have or to use fossil fuels give us the opportunity to create some institutions. I think the one that I would like to share to keep in mind is the Mexican Institute of Petroleum. So we use around the 70s money from spoiling by using oil to invest in this institution and to create knowledge. So We did that around the 50s, 70s, something like that. We have a strong policy perspective with the interaction of the private sector. In this era of early stage of golden age of fossil fuels, all the development was made by the government. Then in the 2008, 2018, it was an electric reform, and it allows the private sector to participate in the generation, only that generation sector. And all distribution was a task that must be done by the government. I would like to highlight that in that same period of time, it was a huge effort to develop these Mexican centers of knowledge related with wind, sun, geo, ocean, bio, and innovation. So that's a huge effort that happens in that era. Today, we have the government has stopped all the permissions to use to integrate into the national electrical grid of renewable energy, in particular large wind farms facilities. They make this stop in the towards this high penetration of renewable energies, because there is some social inconformities about how we were using, or how the wind farms, or how this development was planned, or was being doing. So we have, since 2019, we haven't any more integration of large wind farms. But still, and the last sentence says that we already also have renewed our compromises for 2015 with a 50% of penetration into the electrical grid with clean energy. So we've been stopped in this way to introduce a lot of renewable energy or clean energy. There is a difference between these two sources. Is not the time to talk about it, but we still have compromises. I mean, this transition energy must happen. So we use reanalysis data to model these systems. So if the idea is to have a large penetration of renewable energy into the electrical grids, how can we study the behavior of wind or sun behavior, and how can we match these two variables with the electric demand? So what we've been doing is using reanalysis data. This is a free product that you can download from the SCMWF. It has a grid. It's essentially a global grid when you can download a lot of meteorological variables. Of our interest is wind, of course, and solar radiation. The resolution is about 31 kilometers resolution. It has a time resolution of 1 hour. And we can use, as I said, this information in the specific locations, and to have an idea what's been going on with this production from a retro perspective, right? So it's worth mentioning that this model is a physical model that use some forecasts on some simulation data, and that's why we use, or it is called reanalysis. So the first study case that I would like to share is this. We thought what could happen if we thinking putting some wind turbines into the Gulf of Mexico. So the idea is to identify these regions with high potential using this reanalysis data. We, to estimate power production, we use a 10 megawatt ATU reference wind turbine. Nowadays, there is a 15 megawatts wind turbine that you can also use. We set up some technical restrictions and select some areas, specifically the one that has some portuary development. Among the restrictions, depth is no more than 40 meters, and not that far than 40 kilometers. We use only Mexican economic exclusive zone. Of course, we don't use any natural areas protected. And what we will detect will be the high wind speeds and capacity factors. So by using this wind turbine and by using all wind speeds, we can identify these blue zones when we estimate this large amount of capacity factors well known that we can install wind turbines in the Gulf of Mexico in the sea, because you can get larger extraction of energy, and also it's less variable than the one that can be installed on land. So we identify these points. In particular, I would like to highlight the one that is in the peninsula of Yucatan, that is in your left, and that P1 point, it's for particular interest. So we can use these reanalysis data to identify these potential zones, right? Using this same strategy, now we will study if we can complement these two variables each other, right? So to do that, we use some information that was available, sorry, that was available for 7 anemometric towers. And what we did was to compare reanalysis data information with experimental information to identify how reliable these studies are, right? One thing to highlight is that we use Mexican wind speed atlas information, which was publicly available, and it was a high quality information. So what's the methodology? The methodology is exactly what I said, is just to compare experimental data and interpolated data by ERA 5. And we study how similar these variables are. And then to estimate capacity factors, as in the same case that we did with the wind turbine in the Gulf of Mexico, now we will integrate solar photovoltaic entirely in Mexico. And to identify if we can find complementarity, we use correlation coefficient. So the idea is that if we have the variables occur at the same time, we will have a correlation coefficient near 1. Values near 0 means that we don't have this correlation, and if we have a negative ones, we will have complementarity, right? So the idea is that we would like to find the regions that along the seasons we can spot these regions with high complementarity, okay? So this first slide is just to say that the sun in Mexico is very homogeneous, right? So things happen at the same time. We have a really marked complementarity. What we are looking at is the capacity factors along the weeks. So we divided all the years by week. And these two regions, we have a YY axis. The one on your right is the lighter one. And sun resource in Mexico is very, very similar. So it's a good note. I think it's good. The next is what happens when we compare wind-wind. When we compare wind-wind, we found this indicator of complementarity And it began to raise us a lot of questions because we have found that it could be a win-win complementarity between the blue one, lighter and darker, in the M06, which is two regions that are very far from each other. So this index, it's a good tool to identify this complementarity. And the thing is, what happened when we use solar radiation? When we use solar radiation, we can identify these regions, which could be interconnected, and to provide along the seasons and along the day. Another critical time will be along the daily demand. We are here just discussing about what will happen about along the year. And we may found this complementarity. So what happens if we look at this index? So in the first column, we will see that we have capacity factors, radiations, is very homogeneous capacity production, with solar production in Mexico. It's not the same case when we talk about wind speeds. And when we talk about how can we detect this complementarity within Mexico, we can highlight the peninsula of Yucatan, right? What we are looking at, or what we need is, along all the seasons, these two variables have negative values. And that happens, just to put an example, in the Yucatan Peninsula. I will point that, but I just broke the laser. So this persistent red region in the peninsula of Yucatan offers a very interesting particular case to continue studying, because we can now identify how these variables behave along time and how this can be related with the demand. Also, an important fact is that this region has issues of electricity generation. They have some issues a few years ago when they have these blackouts, and it was because it was a huge demand. So yes, we have a lot of opportunities to implement this methodology. And these opportunities, I think that, well, I didn't want to close this with issues or troubles. 2 minutes, okay? Thank you. So we will have opportunities of studying what will happen with the wind turbine and tropical cyclones. Also, we need to consider that Mexico is a huge region. It's 5 times UK, so it is a complex. What we are looking at the map is the national generation lines. So it is a complex. Now we can identify how the renewable energy will behave along within Mexico, but now we need to integrate it into national electric grid and to study if we can provide some practical solutions, right? So another question will be, well, we did a study of wind power offshore, but we don't know if Mexico, government Mexico has some plans to implement this. How the society will play a key role in implementing these wind turbines in the sea, if that happens. Also, we could say that Mexico has a lot of experience by this institution that I talk about, the Mexican Institute of Petroleum, about putting large infrastructure in the Gulf of Mexico. So it could be not a crazy idea to use all that knowledge to promote a new development. Also, I think that a critical issue in this analysis is to have data availability, right? We couldn't make any of the comparison of solar radiation with wind power if we won't have any experimental data. I think that we implement just an analysis with the 2 main or most popular renewable energy sources, but we can use any other variables and see what can be done. I think that a key issue is that we need the diversification of these generation schemes. we usually take the technology, we install the technology, and we are not making innovation in that. So thank you very much for your time, and happy to be here.
Right, okay. So our third speaker is Lira Luz Lázaro Benítez. Lira is a researcher at the University of Sao Paulo in Brazil. She received a master's and a PhD degree from the Latin American Integration Program at the University of Sao Paulo, and a second PhD on Earth System Science by the National Institute of Space Research in Brazil. Her broad research interests span critical areas such as climate change, climate justice, climate and energy governance, energy transition, policy analysis, institutions and management, corporate social responsibility, and the complex dynamics of the water, energy, food nexus. So thank you, Lira, for accepting the invitation, and the floor is yours.
Thank you, Vanessa. Oops. I am a short person. Okay, now. Okay, good morning. My presentation today is about energy transition, challenge in Brazil, the trilemma and quadrilemma analysis. Brazil's climate change commitment, in special presented to NDC, was two main objectives. The first was attaining 45% of renewables in the energy mix by expanding the use of, for example, solar, wind energies. And the second commitment was to increase the share of biofuels in the energy mix by 18% by expanding biofuels production, in special from sugarcane. Brazil advanced in the expansion of renewable energy source and diversification of its energy mix. The country also developed a lot of research in also the center and innovation in biofuels, in special from sugarcane, also in wind power, solar energy also was significant. But challenges exist in critical areas, in special the just transition, the social conflicts, in special concerning the impacts of renewable energy projects on social communities. Okay. This is some pictures to show these impacts of renewable energy in communities. For example, the first picture is showing about the expansion of solar panels. The question that arises regarding this expansion of solar panel is, okay, the land for food or land for solar panels. The other one is also to show the dominant discourse about the complex, the wind farmers, and this installation of complexities energy. And the other one is about wind energy and impacts on community. There are a lot of conflicts with communities about these impacts with health and other for cattle. And the other is showing the sugarcane harvest burning practices and the emissions of GHG. The question that arises here is what is energy transition, or what energy transition means to government. From this, our research, also our communication to community, also our communication in policy briefs is that energy transition not is simply a shift, for example, from fossil fuels to renewable energy. It goes beyond that and means need to consider social, political factors and dynamics. Also, it needs for holistic approach to studies and research, considering several factors. For example, especially in this picture is showing the interdependencies, also the trade-offs and synergies with a lot of sectors. For example, the use of land, the nexus, for example, of water, energy, and food. And this energy transition, also when we discuss and research energy transition, we need to consider the several factors and consider, for example, the technological advances, also the societal structure, also the regulations and the policy frameworks. Okay, what is the other one about the development of renewable energy programs in Brazil. Okay, and Brazil has the early focus in hydropower. The dependence of hydropower plants in Brazil began to intensify in the 1970s during the first oil crisis. Also from this epoch is the progress in biofuels. Brazil made significant progress in the development of biofuels with launch of pro-alcohol program in the 1970s also. Ethanol produced from sugarcane was identified as a viable option to reduce the dependence from oil, also to reduce the CO2 emissions. And then in the 2000s also become other programs in special as a consequence of climate variability and the water scarcity. And this program was, for example, the ProInfat, that government is the policy government that incentives the diversification of the energy mix. This is the Brazilian energy mix from 1917 to 2020. In this picture is you can see about the evolution of different sources. In special in 1917s, the predominance of the biomass, the traditional biomass. In 2020, the mix, the energy mix is more diverse with the participation, for example, of natural gas and other source. And the other picture is about the end users, in special is the residential, the industrial, and the transport sector is the two sectors that consume most energy. But the difference in this is that industrial sector consume more renewable energy, and transport sector consume fossil fuel. But the electricity mix is different that energy mix. In the electricity mix, the predominance is from hydropower. That dominate the electricity. Also the participation of wind, solar, biomass is more, the electricity mix is more renewable. Okay, but the challenge, but exists a challenge, as I mentioned recently, about social conflicts, also the concerning about the climate variability. For example, this picture is about the river Amazon, about the Amazon forest. The picture is from November of the last year to show the impact of climate variability in the environment, also to show that water is impacted by climate variability, and also to rethink against these predominant discourses and narratives that water abundance. Okay, the other one is about energy transition trilemma and quadrilemma. This is our research about the Brazilian government understand about energy transition. Okay, and the dominant discourse, also the narratives in Brazil, is that Brazil reach almost 100% of electricity access. And our research is showing that this is not true, because there are a lot of population, also communities without electricity access. One of the program, the important program in energy that the Brazilian government launched was the program Light for All, or energy, or access to energy for all. This program has made significant progress in increasing access to electricity, reaching almost 70 million people. But the problem is that there are 22% of households that is suffering to pay the energy bill. In this point, I raise all question about, okay, energy transition, energy for what? Energy for whom? If energy or energy transition, what does mean energy transition? Is only think in offer energy for population, that also we need to consider if population is capable to pay, for example, the energy bills. Okay, this is the results of our research about energy trilemma and quadrilemma. We consider the dimensions such as energy equity, energy security, environmental sustainability, also the context dimension about governance and socioeconomic indicator. Okay, I said that Brazilian government discourse focus on almost 100% of access of electricity, but this oversimplification neglects the diverse and the complex of the energy system in different regions, or in different Brazilian regions. This is our result in the 5 Brazilian regions, from north to south. Our finding is identify and reveal the complex and diverse challenges faced by Brazil region. For example, the low scores on sanitation indicator in the north of the country, also in the northeast, indicate the deep-rooted social inequalities in the region. Also, the other indicator was about the low thermal comfort, indicating serious problems in the country and the risk for health problems. In special, our study identified the North region problem. The North region is the rich region with several resources. Also, the Amazon forest plays in this region, but is the region faces numerous challenges, resulting in higher poverty if compared with other regions of the country. This is the Brazilian map, in special in. Okay, the North regions is the most power, or also is the more poor, also needs the access to electricity. And from these results arise several questions about policy, also to consider not only the energy transition, also about energy poverty, also about just transition. What this means, energy transition is only the shift from fossil fuel to renewable. And from the academia, from my group, we are communicating to the society, to the government, saying that okay, we need energy transition, but this energy transition needs be with inclusion. Also, we identify the relationship of energy poverty and gender. In many contexts, the woman suffer from the energy poverty, because the lack of energy impacts in health, in education, also in the economic conditions. Especially in Brazil, in the last decades, woman is headed the family, and our study is showing this energy poverty, in special in the woman, and is showing also this relationship in energy poverty and gender. To illustrate this, this energy poverty, our other study is in the city of Sao Paulo. That is showing this expansion of solar energy, also with socioeconomic indicator. And this is showing how this expansion of solar energy is concentrated in rich and healthier neighborhoods, but in the neighborhood, the poorest neighborhood, there is these solar panels. From these results, our criticism to the government was that government not is considering this energy transition, this expansion, the expansion of solar or wind energy to poor population, and regulation, also the policies need to consider also poor peoples. Especially in these graphs is showing, example, the population that is, the majority is Black people or brown people. There isn't panel solars. The panel solars was expanded in rich in rich neighborhoods. Okay, this is my presentation today. Thank you so much.
And then we will invite the audience to make questions and comments about the three presentations.
So if you're there you go. If you're going to ask a question, please introduce yourself and your affiliation. There. Here in the front.
Good morning. My name is Efraín Moreles from Mexico, from the National Autonomous University of Mexico. Thank you for your presentation. Why is it so difficult to achieve a complete energy transition? What would happen if our policymakers were scientists?
Who wants to start?
Well, I believe that the energy transition must need a multidisciplinary point of view. We talked with Hector and with Vanessa at breakfast just this issue. The energy transition not is only a technical problems. It's a problems that involve engineering, economics, anthropology, sociology. It's really a problems or a challenge that imply an interdisciplinary work, and it's very important that this work that we do in our university, in our institute, can transfer to the political, can transfer to the people that take the decisions in the political aspect. Then I don't know if I answered your questions, but I believe that there must be a very hard link between the science and the political government in relation or related to the energy transition. I don't know if you think.
Yeah, also when we talk about energy transition, it's very important to know what is energy transition for government, or what should be energy transition, for example, for Brazil, or also for other Latin American countries. The dominance discourse also that the social media, also the media or the companies is communicating is we need to transit. We need the energy transition to face to climate change, to reduce greenhouse emissions, but energy transitions goes beyond that. Not is only the shift from fossil fuels to renewable. It's complex, there are several factors, in special the social dimension, also the political and the policy wheels. If, for example, Mexican government is concerned about energy transition and needs to transit to renewable or energies or not, also need this collaboration and cooperation with social scientists, with other colleagues from the hard science, for example, to communicate, to better communicate to the society, also to our politician, to decision maker.
Yes, just I think that the issue, it's a creativity issue, because you need to. We have a very successful scheme of using renewable energies around the world, right? But we don't know if in our Latin American context, this is the proper way to use renewable energy. I think that also a key word will be fair transition. We have a lot of issues and social issues. How can we use these abundant resources in Latin America to promote development, because we also have the issue of renewable energy, but also the poverty, right? So how can we use this energy to also continue developing? So I think that we need, yes, inform decision makers, but also we need to be more involved in this process.
Other issue is how is the cost for our economy for the energy transition? Because go toward renewable energy, green energy, is very costly for our economies. Because, for example, Argentina import all aeolic part of the aerogenerator. And this is very cost for Argentina, very costly. Then how is the cost for our economies? We know that we help the world to do the energy transitions. But how? This is, I believe, the problem, the issue that we must talk in the university, in the institute.
Only to complement. Okay.
To the next question, please. We go here, one on the front. Guess the new.
Good morning. Thank you very much for your time and for your insights. My name is Ramón Emilio de Jesús from the Dominican Republic, from the Pontificia Universidad Católica Madre Maestra. And having said that, you mentioned when talking about energy transition, you have to talk about money, you have to talk about cost, right? When exploring the issue of energy justice for communities, that's the central question, right? And our research group is wondering, the hypothesis or the research question is, should the government put targeted incentives for specific communities? Like the current tax cuts for solar penetration are just a fixed number. It's 40% on the installation of the panels for any industry, any sector. What has happened is that these incentives have benefited a very specific part of the industry or the population, right? And then you have, as Lira mentioned, some part of cities that have this penetration and others cannot access this transition, right? So should the government, or is there a possibility for a specific tax cuts for example, residential instead of only industry? And I haven't seen it around, I've been poking around, but I haven't, it's a thought process that I think we should all talk about. Should these incentives be for communities that need it instead of just only industry or companies that can otherwise find ways to finance these type of installations? Thank you.
Yes, I think that the solution of renewable energy is not only one solution. It's not only putting large wind farms. I mean, the thing of the creativity, I think, is that we need to think own the own schemes how to use renewable energy, and that's the creativity issue, because we don't know which are the needs because we are in different locations, right? So I think that good thing about the models that I introduced, that it provides you this guide of the abundance of the resource, and if this can be matched with local specific necessities, right? So I think that I insist is to innovate in the solutions, to adopt them, and not only to receive the technology or the solution. We need to propose which scheme will be the adequate for the region. I think it should be diverse and in different levels.
Jorge Huete from Georgetown University, originally from Nicaragua. I understand your positions regarding the fact that we cannot switch to clean tech energies right away. It's a process. I'm aware of all of that, but I think it would be interesting to also discuss what are the efforts that countries are doing in terms of improving the investment in new technologies and emerging technologies. If we look at the represented countries like Brazil, Argentina, and Mexico, I don't think there's much investment in general in science and in R&D. So, could you speak a little bit about that regarding clean energies?
Yes. Well, in the specific case of Mexico, the last motor or project promoted towards innovation was the one that I'll show in the slides. So it promotes some investment with some specific targets. In the specific case of the Mexican Centers of Innovation in energía eólica and wind power. So the thing was, the plan was to provide services of blades, by example. This was this project, and the idea was to construct this chain of services with the wind turbines, and then the idea is to promote the human development in this regard, right? To provide this maintenance for blades. So it was a good project. I mean, this is just one example of how this project detonate. It was a project of 2 or 3 years. I don't know, Vanessa can correct me, please. And the idea is to promote this equipment and the human resource formation. But now we've been stopped. All the renewable energy research has been stopped by from 2019. So we don't have any more investment in this regard. So the issue is that what will happen with all the infrastructure created and all the human resources formed that have some knowledge but have some skills that actually are not used, right, to provide services. The general idea was to provide services and small industries to promote energy transition.
In Brazil, Brazil has one of success history is the program of bioenergy. But this program of bioenergy, the ProAlcor program, was in 1970s. But notice the same in this time. For example, the wind or solar energy needs more incentives from government. The majority of these projects is from companies. There are several discussions about this from academia, for example, to identify but what's the problem with this, with the government or the policy incentives to modern renewables energy. One of the issue is the pre-salt discovery, because the pre-salt for Brazil is the golden goose. Also, the majority of the investment from the government is addressed to Petrobras, to pre-salt, also to oil and gas source. Another question is, another topic is about barriers, the energy transition barriers. One is the technological barriers, the dependence from foreign technology. The other is the dependence of oil or fossil fuel income. The country needs incomes from pre-salt, from oil, from Petrobras to economic development.
Well, in Argentina, we have a company, a public and private company named YPF. That is the company that produces natural gas and petroleum. And this company currently is moving toward an important effort to do innovation in hydrogen change value. For example, YPF is working in doing electrolyzers, own electrolyzers, national electrolyzers for the hydrogen change value with the relation with the universities. Then I believe that is an important work that link innovation, technology, science in one theme of the energy transition, that is hydrogen. That is the experience of my country related to innovation. And there are a lot of innovation in natural gas change because my country has more than 60% of his energy matrix by natural gas. The same of Lira talk about Brazil occur in Argentina. Then in my country, there are a lot of innovation in natural gas change and in hydrogen change.
Just a quick comment on that. In terms of research, I would say that if you look at the funding, you'll see that either you get more points if you work in this area, or definitely the college on the area. So I would say that in general, from my perspective, the money for research is being placed for these activities, and it's growing.
Hello, I'm Luciana from University of São Paulo, Brazil. Thank you for your presentation. Going back a little bit to the first question and what you said, that we need to establish this dialogue between science, policy, communities, and such dialogues takes time. And what we see is that there is a rush for establishing the infrastructure for energy transition if we want to reach our goals in the close future. I want you to share with us, if you have this experience, how are these dialogues being actually performed? Is there this space? Are you getting to reach the policymakers? Are communities actually being heard in this process? So share with us a little bit of your experience, please.
Well, I believe, for example, in my country, the past government talk with the research, with the university, and help about energy transition. And I believe that in my country currently has a lot of economic problems, as you know. But I believe there are a dialogue, a construction between university, science, and government related to climate change, to energy transition, to different possibility to do the energy transition, knowing that we have a lot of gas and we need to do the energy transition with gas. But perhaps the gas will be the link in my country, no? Perhaps the gas, the natural gas, will be the link between fossil fuels to renewable energy. I believe that country as like Argentina don't think do the energy transition without his own resources. I believe that is the key. The key is, and the key that we must talk in the science and in the government, that how we do the energy transition with own endowment.
In Brazil, the energy policy is oil-centered. The solution is the techno-economic solution. The energy planning also is more technical. As consequence, in decision-making, not is considering, for example, about communities, population, or the society perception. What is the perception or what is the belief of communities regarding, for example, wind projects or solar panels expansion? Not is considering from this our communication also is in this direction and saying, okay, we need also to pay attention the society perception and the response. What's the response? Because the innovation and technologies need also from the perception also of the acceptance of the social and of the society.
Thank you. At the beginnings of this current government, I participated in some planning meetings. However, they defined different priorities, and the issue of renewable energy was focused in energy for everyone, I think it will be the translation. So it was oriented to provide energy into isolated systems. So that's how it ends this government vision into investment into research. Now we are in a period of elections, and one of the candidates, it's a researcher from our university, and also has this, I don't want to be very political, I mean, it's just the fact that she has this formation, right, in renewable energy. So I think maybe she could be more sensitive in this regard. But also we've been assessing some local governments, looking into how the potential they have in their states to promote local development, right, and the investment. So we've been talking with the decision makers, but I think they have different priorities. And when the federal government has defined it, and it's very rare that a local government goes the other way.
Hi, my name is Antonio Quispe. I'm from Peru, and I research at University of Technology and my question is related to, we're in the middle of a climate crisis. So the hydroelectric source is one of the ones that every country in Latin America is depending from, that is decreasing dramatically. And the other source that is increasing is actually the sun. So in each of your countries, you're presenting some experience about how to produce the solar panels or how to distribute it. But I was curious about the microeconomy behind it, because neither of you have talked much about the people itself, about the consumers of that. In Peru, the latest revolution in that field was that the solar heaters of water, because in the highlands, they have a lot of a company developed those and make a huge impact in those communities, changing the source for the people to heat the water, and that's preventing pneumonia and all those sorts of diseases. So what is the latest experience scaling up these attempts to promote micro use of solar panels in your countries?
Okay, so what happened in Mexico is that we have a subsidy for energy, electricity. So it is harder to get some PV system unless you are in a high tariff demand. So you have people with higher necessities of electricity, I mean, with higher demands, and they pay more, or they pay the real price of the electricity. And then they have, there are some industry around that they give you a loan for the PV system, and you pay for this PV system, and it returns. So the return period will be like 7 or 10 years, something like that. And so it is very focused, the population that can access to this, right? Because you need to consume a lot of energy. And people will have no access to electricity. In this regard was this National Council's program in research towards how to provide energy, how to supply the energy in these isolated systems. So from a user's perspective, I think that it is very localized who is using PV systems now. Because in Mexico, we don't pay the real price of the electricity. Well, home user, right?
In Brazil, one of our study was with interviews in the city of Olambra in Sao Paulo state. This municipality, this city of Olambra is the city that that adopted solar energy. One of our questions of this interview to prosumers was, what was your motivation to the adoption of solar energy? Is environmental concern, or is the economic issue? The majority of the response was because the energy bill is high. I need to reduce my energy bills. and the environmental concept. Okay, I concern about climate change, about environment, but the economic reason is my first option. For example, this study.
Well, Argentina. Argentina has the same problem of Mexico. We have subsidized the energy prices, and this is a problem for energy efficiency policies. It's a problem for introduce solar energy in our energy matrix, because when the energy is cheap, the population not increase, not do effort to introduce energy efficient policies in their homes, don't introduce energy efficiency policies in the university, the population don't introduce solar equipment in their home, because the electricity is cheap in Argentina. It's very cheap. We are in this moment in a transformation, in a great process of transformation of our energy matrix, and the focus of our transformation is align the energy cost production with the energy prices. This is in this moment the key issue in Argentina. How we can align the cost production of energy with the price of the energy. And if we can do this issue, we can put more policies of renewable energy. We can put policies of environment related to energy. We can put energy efficiency policies. This is the issue in Argentina currently.
We will take one more question. I think
Yeah.
there was one at the back. Yeah.
Hi, my name is Andrea Sangil. I am from the Center for Urban Sustainability and the Global Network for Popular Transportation. It's kind of weird to be the last one to ask a question / comment, but I think it's really important that we haven't mentioned certain concepts in this discussion, and it will lead me to a question. I will get there. You've talked a lot about cost, but I would like to remind everyone that it is also very costly to continue to extract fossil fuels. And we were all here when our colleagues talked about the impacts on oceans, and we all know about the health costs and the pollution costs. So I think when we talk about cost, we need to talk about externalities as well. And there's another concept that we haven't talked about, which is lock-in. If we invest now in continue to extract fossil fuels, and fossil fuels include natural gas, we will be trapped in loans and infrastructure and production that will keep us there for 30, 40, 50 years. So when we talk about cost, we also need to talk about how this will affect our economic model long term, and how the investment decisions that we decide to do today will basically define our economic model and our production model for the next decades. So I think my question would be, why are we not talking about lock-in, and why are we just talking about production costs and not the wider externalities to health, and not only financial costs, but the wider economic costs, not only for our countries, but also for the other people around the world who are right now being impacted by the climate crisis, and it will only get worse if we continue this model. Thank you.
Thank you. Yes, I totally agree. I mean, I'm renewable energy fan. I mean, I think that the big thing is that we need to to reduce or to tackle these very traditional issues that we cannot use variable sources into the electrical grid, right? Because by the last 100 years or more, we've been producing electricity one way, and generate electricity by renewable energy. It's a change of paradigm. I mean, it is totally different. You can't manage the grid in the way that you've been doing it by the last 100 years. So this energy transition, I think, that need to address this issue also, how to integrate variable energy. So, and I insist, is variable energy and the variable demand, and how to interconnect resources. So it's a different way to plan the issue, right? And also, I think that the solution is not large scale only. I mean, I think that it should be a local way to use these renewable energy sources, right? Everyone should have the opportunity to access energy, right?
I believe that I agree with you. First of all, I agree with you. But I intend to explain that for my country is poor. And there are a lot of people, there are a lot of part of the population poor. And introduce a lot of renewable energy in our matrix is very costly for our economy. And we have, for example, gas. And I believe, this is my point of view, my sincerely point of view. I believe that we need to resolve the problem of the poor in my country. And one part of the solution is use the natural gas that we have. I agree with you that is a fossil fuel, that is pollutant, but we need to resolve other terrible problems of our economies. And then the question and the issue is, what is the first? The population of the environment? I don't know. Yes, it's together, but how can't reduce this together in a politic? This is the challenge for our economies. And because we are in country that one part of the population are poor, then yes, the environment is a necessity, and we talked yesterday and today about this. But how can reduce the poverty, the energy poverty in our country? With renewable energy, with gas? I don't know. This is the discussion.
Well, folks, we run out of time. It's been a very interesting discussion. I invite you to keep on these questions. We are happy to talk, and I hope you guys talk about this because it's a big problem. I would like to thank you, our panelists. Please, a big applause. And Vanessa, I don't know if you want to say something.
No, thank you very much. And I think it's time for lunch.
Yes. So we have an hour and 15 minutes for lunch. So our next session will start here at 1:15.
This will live here. There's a microphone.
Yes. So, Thank you. Yeah, thank you.
Explora más contenidos de tu interés. No olvides suscribirte a nuestro canal.